Let's look at three sloppy data sets that are not normalized and see the challenge that we need to do. Here we have these mini ranges. All the way down, there's a whole bunch of these, and what we want to do for each combination of division and year, we want to add up the numbers, but only when the second word is always two words above each of these little mini tables. Only add it up when the second word is total. Second challenge is this. We have all these mini boxes going from left to right. We have sales and profit in each one of the boxes, but we have a different piece of equipment here across the top. And we want to average the sales and the profit for the two different people in here, which is Herman and George. And finally, in challenge 3, we have the data normalized. Category is in column A, number is in column B, but the total that we want to extract out of here is when these are sorted together, and in each of these little ranges, the last item, that's the total. So here, they're all the same group. The last one, that's the total, and the same here. The last one is the total, and we want to extract that. Now, normally, we would always tell you that you should do this. You should normalize your data, and always after that, it's easy to add some formulas or some pivots, right? So everything is in the columns. Every different piece of information is in a column. So let's go back over here. That would mean for this kind of data set, you'd do this over here. Let me just delete that little box. So you'd have business unit, year, and data. Now we'd also have to have a column that would say yes or no because of this word here. This is a key word, the total. So we'd also have that over here. We'll have to put in a yes or no to include or not include, because here for this table we ignore all the numbers, we don't add them, but we include all of these because we have the word total. And then in the challenge number 2, we want to take this data, and normally we would say normalize it into something like this. We have the name, we have the equipment, sales, and profit. Then we can do a quick pivot table, or maybe we do some quick average ifs. Challenge number 3, this is a little bit different because we already have a category here and we have the number here. We don't really have to rearrange anything, but we can still use the same solution that we're going to use for these other two. So let's come back here for a minute and look at this part. Now, there is another possibility. We could use, I'm not even sure of the right term, but I call it formulas with sliding ranges. You'd almost never ever want to do this, but there are times when this could be an incredible solution. So let's take a look here. Here we have a little sort of questionnaire. Is this a quick one-time task, or is it a long-term project? If it's a long-term project, then you definitely want to restructure the data like we have over here and do it the proper way for the long term. Take these sloppy data sets like this one, all these mini tables, or this one, many little groups going from left to right, and normalize it like you have here or here. You'd almost always want to do that. But if it's a one-time task and you just want to quickly get an answer and there's not many questions, it's just very limited number of questions, you could possibly save a lot of time and just use these sliding ranges. Now, let's look at the solutions. Here in the first one, this solution was suggested by Diarmuid Early, who's a model off champion, because I did a separate video on a long way of solving this using a helper column. But look at the formula in here. Look at how we've got, I've got the whole explanation down here. You could pause the video and read this, but basically, note how this is not locked at all. The sum range is not locked at all. So when we drag it over to the right and drag it down, it's going to change. This whole solution is built on the fact that these divisions are always in the same order. If they're not always in the same order, then this wouldn't work. But in this case, they are. So we have this sum range, which is totally not locked. Then we have our criteria range. The column D, we always want to lock it on the division, because that's always going to be the criteria. But the rows are not locked. So when we go down, we see how that changes. And then let's go back and look at, in the first cell, look at our column F. Column F has the criteria. Is this word here, the first word in our range, is it equal to the word total? So that's kind of how this whole thing works. At first it takes some time to understand it, but then it's brilliant because there are no helpers. all we have are these just the sum ifs that are in this range. So we've got 20 of them. We got 20 formulas. That's all that we need. There's all sorts of crazy ways where you could use VBA or helper columns or get and transform to normalize this to get this exact same answer. So in extreme cases, these sliding ranges, because I don't know any other way to describe them, but this would solve it very easily and very quickly. Now let's look at solution number 2. It's the same kind of thing, just a simple formula, not an array formula, not a sum product, nothing complicated. And we're just looking at this and we have these sliding, right, where it slides over, or overlapping ranges. See how the blue one starts here? The sum range is columns B to Q. Our criteria is the name here, Herman, and then our sum range is from column C to column R. Now, if we go over to profit, it's a little bit different because we slide it over to start with the profit. So this is really amazing. You could do this in just a few seconds compared to trying to normalize this into a proper data set like we have over here. This will take quite a bit longer. Once again, it's better for the long term to do this, but if it's a quick thing, you might be able to use these sliding ranges. And finally, the third one here, yes, it's a little bit different, but we can use a similar approach. We could use a helper column, but what I did was just an array formula. And I have these ranges which are overlapping to say, hey, if A2 is not equal to A3, that means comparing the first one always to the second one. So we get down here, and it's the first time it's true that this one is not equal to that one. That's what this array is doing. Comparing true false, here's our logical test, all the way down. Every time it's different, meaning these two are different, these two are different, and down here, this one with the blank is different, not the same. Whenever it's true, we get the row numbers. And I just use the small function to say extract them one by one using my counter here in column I. So I get the row numbers, row 7, row 13, row 22, and then I simply use an index beside it to pull out those answers. So, as I always say, most of the time you should really normalize your data. But once in a while you can try something like this, and if it's just a quick thing, you could save a ton of time. So if you like my video, come over here and download the file. I'll have a link here where you can download it, or look underneath the video and give me a thumbs up.